Crosstex is a recognized leader for its portfolio of personal protection equipment, PPE, disinfection and cleaning chemistries, sterility assurance indicators, sterilization packaging, and single-use disposable products. Crosstex products are sold throughout the world in more than 100 countries. Combine this with 12 strategically located manufacturing and distribution facilities around the world, and you begin to understand the broad reach and impact of Crosstex in the healthcare industry. We are dedicated to delivering innovation, infection prevention and control, IPNC, for our patients, caregivers, and other healthcare providers, which improve outcomes and saves lives. The Centers for Disease Control and Prevention, CDC, and U.S. Food and Drug Administration, FDA, alerted healthcare providers and facilities about the public health need to properly maintain, clean, and disinfect or sterilize reusable medical devices. Recent infection control lapses due to non-compliance with recommended reprocessing procedures highlight a critical gap in patient safety. Since that time, the Food and Drug Administration and the CDC, along with healthcare accrediting organizations, professional and standard-setting organizations, along with government agencies, are promoting awareness, collaboration, and to address the challenges of reprocessing. Reusable medical devices are devices that healthcare providers can reuse to diagnose and treat multiple patients. Examples of reusable medical devices include surgical forceps, endoscopes, and stethoscopes. When used on patients, reusable devices become soiled and contaminated with microorganisms. To avoid any risk of infection by a contaminated device, reusable devices undergo reprocessing, a detailed, multi-step process to clean and then disinfect or sterilize them. Consistent, standards-based reprocessing of reusable medical devices is vital to protecting patient safety. In the U.S., medical device reprocessing best practices are detailed in CDC guidelines for high-level disinfection and sterilization, AAMI standards, AORN guidelines for perioperative practices, along with other documents such as SGNA, which focuses on HLD of flexible gastrointestinal endoscopes. The consensus includes 7 recommended steps based on best practice standards for medical devices and instrument processing. We begin with the point of use preparation, followed by transportation, cleaning and inspection, packaging, high-level disinfection or sterilization, quality assurance, and ultimately storage and delivery. Each step is based on specific procedures according to the guidelines, which can be implemented and managed at any type or size of medical facility. Point of use preparation. This step begins with removing and properly disposing of all non-reusable items, such as tubing and packaging, etc. The point of use preparation involves pre-cleaning the reusable equipment or instruments with a cleaner that meets manufacturer specifications. It is important to use the right type of cleaner to avoid damage to the equipment and warranty issues. Transportation. All reusable medical equipment that is being transported for reprocessing should be considered contaminated based on the practice of universal or standard precautions. The equipment should be handled while using the appropriate personal protective equipment to prevent the spread of infection. Contaminated devices should then be placed in a sealed, leak-proof container prior to transport. The container must display a visible biohazard symbol and be transported to the processing area. It is important to know the proper donning and doffing of PPE to avoid cross-contamination and the importance of hand sanitizing after the removal of PPE. Cleaning. Once you've arrived at the processing or decontamination area, it is important to gather any tools, personal protective equipment, and supplies prior to opening the container holding the contaminated equipment. While wearing appropriate PPE, remove the equipment from the container and place it in the designated area. Begin by manually or mechanically cleaning the soiled instruments as soon as possible. Prompt cleaning removes blood and bodily fluids much easier and can minimize staining, corrosion, and/or pitting. It's important to clean instruments in solution and not above solution surface. The Occupational Health and Safety Administration, OSHA, requires that employers provide employees with personal protective equipment for protection against bloodborne pathogens, BBP, and other potentially infectious material, OPIM. Types of PPE used in healthcare include gloves, fluid-resistant gloves, masks or respirators, goggles or face shields, impervious aprons, gowns, and shoe covers. Make sure to clean instrument under the water level to not create aerosol droplets. When cleaning reusable equipment, be sure to use approved cleaning solutions, tools, and cleaning brushes. Unapproved cleaning solutions and commercial products not intended for use on medical instruments can cause damage or limit the intended effectiveness. Reusable brushes and other tools should be cleaned, disinfected as needed, and no less than at the end of each shift. Disposable brushes should not be reused, even if disinfected, and should be discarded after each use. OSHA requires that cleaning solutions must be clearly labeled, and it is best practice to dispense using a pre-measured pump or be a ready-to-use solution. Chemicals should not be poured into sinks or containers without being properly measured. When not in use, chemicals and supplies should be kept organized and sealed to prevent accidental spills. When manual cleaning is complete, thoroughly rinse instruments with tap water to ensure that all debris and detergent residue is removed. Rinsing should be performed in a separate clean sink or basin. It is important to follow cleaning detergent manufacturers' IFU regarding the number of rinses to be performed.
The following video is intended to provide a basic overview of how to use Rapicide OPA28 high-level disinfectant for processing heat-sensitive semi-critical medical devices. This presentation does not take the place of the instructions for use, which come with the product and must be read prior to use. Rapicide OPA28 high-level disinfectant should not be used to reprocess any urological instrumentation that is used for cystoscopy or other urological procedures for patients with a history of bladder cancer. In rare instances, similar orthophosphoraldehyde or OPA-based disinfectants have been associated with anaphylaxis-like reactions in bladder cancer patients undergoing repeated cystoscopies. Rapicide OPA28 high-level disinfectant should not be used to reprocess any instrumentation for patients with known sensitivity to similar OPA disinfectant solutions. Avoid contact with eyes, skin, or clothing. Always read the bottle label and package insert before using Rapicide OPA28 solution. Welcome to the Rapicide OPA28 high-level disinfectant in-service training program. Crosstex has developed this program to help you learn how to use Rapicide OPA28 high-level disinfectant when reprocessing flexible endoscopes, either manually or in automated endoscope reprocessors, also known as AERs. This video gives basic information about Rapicide OPA28 high-level disinfectant, or HLD, and how to change out and reprocess with Rapicide OPA28, along with the proper storage and disposal of Rapicide OPA28. Rapicide OPA28 high-level disinfectant provides a superior way to reprocess heat-sensitive, semi-critical medical devices that are unsuitable for sterilization. Rapicide OPA28 features 5-minute AER disinfection contact time, 10-minute manual disinfection contact time, 28-day reuse life, which is twice the reuse period of 14-day OPA brands, with guaranteed materials compatibility, which allows for the ultimate combination of safety, convenience, and value. Rapicide OPA28 10-minute manual disinfection contact time provides 1 extra disinfection cycle for every 5 instruments reprocessed, compared to 12-minute OPA, allowing you to reprocess 1 extra scope per hour and reduce downtime of medical devices. Rapicide OPA28 is supplied ready to use and does not require activation. Instrument cleaning is a crucial part of the decontamination process. Instrument cleaning and decontamination should occur immediately after the procedure and before reprocessing to prevent soil from drying and to prevent the formation of biofilm. Crosstex recommends Crosstex Sani-Prozyme enzymatic detergent for ultrasonic or manual cleaning. Enzymes in detergents like Crosstex Sani-Prozyme enzymatic detergent are specially formulated to break down or digest the organic soils, so the detergent can remove them without being redeposited on the cleaned instrument surface. Make sure to follow your department's policy and procedures for proper cleaning. The medical device manufacturer's validated reprocessing instructions for use, or IFU, should also be available and followed. General cleaning and decontamination guidelines are available from industry associations such as AORN, AAMI, and SGNA for additional information about cleaning standards and practices. Personal protection equipment, or PPE, must always be worn when handling contaminated instruments and equipment to protect skin, eyes, mucous membranes, and clothing from splashes. Always follow your department's procedure for wearing PPE when high-level disinfecting. Crosstex recommends the use of Crosstex Secure Fit face masks for face protection, featuring dual aluminum strips above the nose and under the chin. The patent-pending design eliminates gaps, increases protection, and greatly reduces fogging while maximizing breathability and comfort. Wear Crosstex face shields along with Crosstex Secure Fit face masks, gloves of appropriate length, and fluid-resistant gowns when disinfecting devices with Rapicide OPA 28. Let's review the changeout and disinfection procedure for Rapicide HLD when using an AER. Rapicide OPA 28 high-level disinfectant has been validated for use in the Medivators DSD-201, SSD-102, CER1 Optima, and CER2 Optima automated reprocessors, and the CER1 and CER2. Make sure to consult both the AER and medical device manufacturer's IFU, which comes with the equipment and must be read prior to use. In this example, we will be using the Medivators DSD-201 Dual Basin AER. To clean out when switching from one type of disinfectant to another in the Medivators DSD reprocessor, follow these steps. Remove the existing disinfectant by evacuating the existing disinfectant from the reservoir tank. This can be done by pressing the disinfectant dump and start keys on the AER control panel. Visually ensure that the reservoir tank is empty. Remove the tank and wipe it clean with a damp, lint-free cloth. Refit the tank in the machine. Fill the reservoir tank with fresh water. Run 2 standard cycles with the fresh water and dump again, using the same control panel process as before. The Rapicide HLD solution is now ready to be added. Open the bottle of Rapicide OPA 28 high-level disinfectant. Make sure to have the department's reprocessing log available and record the date the solution was poured on the container label or in the logbook. If any solution is remaining in the original bottle, tightly secure the cap and record the new expiration date on the bottle. The new expiration date must not exceed the original expiration date on the bottle. High-level disinfection requires appropriate temperature, contact time, and length of use following solution activation. Always confirm the temperature of the solution in the holding tank is at least 20 degrees Celsius. Next, determine whether the concentration of OPA, the active ingredient in Rapicide OPA 28 solution, is above or below the established minimum recommended concentration, or MRC, of 0.35% by using Rapicide OPA 28 test strips. Immerse the entire indicator pad on the test strip into the Rapicide OPA 28 solution for a full 3 seconds. Remove the strip and touch the long edge on the paper towel to remove any excess Rapicide OPA 28 HLD solution. Lay the strip pad side up on a paper towel and start a timer for 90 seconds. Compare the indicator pad to the color blocks on the test strip bottle at exactly 90 seconds and interpret the result. The color of the indicator pad will be green when the concentration of OPA is above the 0.35% MRC. Make sure to test the solution before each disinfection. The Rapicide OPA 28 HLD solution can be used for a period up to 28 days, provided that prior to each use, the concentration of OPA in the solution is verified using Rapicide OPA 28 test strips to be above the MRC of 0.35%. The solution must be discarded after 28 days. After MRC testing is complete, fill the AER with the Rapicide OPA 28 HLD solution. Be sure to refer to the daily preventive maintenance check sheet for a day-to-day preventive maintenance. To run the reprocessing cycle, close the lid and secure. Select the appropriate cycle and select Start to begin. Perform the automated disinfection cycle in accordance with the AER manufacturer's IFU. Be sure to select a cycle that has been validated for use with OPA-based disinfectants and the scope manufacturer's IFU. When the cycle is complete, verify that the stop LED is illuminated before opening the lid and removing the scope. Now, let's review how Rapicide OPA28 HLD is used in manual reprocessing. Follow the same steps as before for testing the MRC of the Rapicide OPA28 HLD solution. Place the pre-clean scope into the manual holding tank that contains the Rapicide OPA28 HLD solution. Immerse the device completely in the Rapicide OPA28 HLD solution at or above 0.35% OPA for a minimum of 10 minutes at room temperature, which should be a minimum of 20 degrees Celsius. Make sure all lumens are filled. Remove the device from the solution and rinse thoroughly according to the device manufacturer's rinsing instructions. In the absence of the device manufacturer's rinsing instructions, thoroughly rinse by immersing in a large volume of water. Keep the device entirely submerged while rinsing. Always use fresh volumes of water for each rinse. Do not reuse the water for rinsing for any other purpose. Repeat the procedure 2 additional times for a total of 3 rinses with large volumes of fresh water to remove any residue. 3 separate large volume water immersion rinses are required unless otherwise specified by device manufacturer's instructions. Refer to the medical device manufacturer's IFU for drying. Be sure to follow any state, local, or department disposal regulations when disposing Rapicide HLD, unless otherwise specified. Rapicide OPA28 HLD can be safely discarded down the drain, making sure to flush thoroughly with water. Store Rapicide OPA28 in its original sealed container at a controlled room temperature of 15 degrees Celsius to 25 degrees Celsius, or 59 degrees Fahrenheit to 77 degrees Fahrenheit in a well-ventilated area. Once opened, the unused portion of the solution may be stored in its original container for up to 75 days until used. Flexible endoscopes are some of the most challenging medical devices for healthcare facilities to reprocess due to their unique design and complex reprocessing steps. But through strict adherence to standards and best practices, such as those set forth by AAMI, AORN, and SGNA, healthcare facilities and those responsible for the reprocessing of heat-sensitive semi-critical medical devices can feel confident that quality and patient safety will not be compromised when using Rapicide OPA28 high-level disinfectant. For additional product or ordering information, or to learn more, be sure to visit OPA28.com. Email info@spsmedical.com or call 800-722-1529. +1 585 359 0130.
Mechanical cleaning with ultrasonic equipment or instrument washers can be used in addition to the manual cleaning that was performed. If mechanically cleaning instruments or scopes, it is extremely important to follow the manufacturer's IFU for the equipment and the chemicals. Inspection. Each instrument should be critically inspected after each cleaning to check for residual debris or damage. If you can scrape or brush off a substance on an instrument that has been cleaned, it needs to be rejected and cleaned again. If the instrument is showing signs of wear, is broken, or is not able to be cleaned properly, it should be placed in a bin or container for repair or disposal according to your organization's disposal policy. Packaging. Instruments should be packaged in a location that is clean and separated from decontamination and soiled equipment holding areas. Instruments should be packaged using FDA-cleared products such as a sterilization pouch, wrap, or container. Sterilization pouches are for packaging loose instruments and small, lightweight items. Paper and plastic pouches provide visibility to see the contents and are designed with an adhesive strip for sealing. It is important to remove all excess air prior to sealing the sterilization pouches to prevent contamination. Chemical or steam indicators are used to confirm that the contents of the pouch achieved the specified temperature for the appropriate duration in the interior of the sterilizer. The CDC guidelines requires that mechanical indicators are also recorded, such as time and temperature. Maintaining a log of these records is an important quality assurance step to be discussed later. To assist the sterilization process and aid drying, place pouches facing each other and on the edge using a divider. Pouch dividers are commercially available to accommodate different size sterilizers. FDA-cleared sterilization wrap is ideal for packaging surgical kits. The industry standard is to use 2 layers of wrap per kit. It is important to select the wrap which complies with manufacturer's FDA-cleared wrap. For quality assurance, include a chemical indicator on the inside of the wrap to verify the sterilant reached the inside of the package. Wrap in a way that allows sterile presentation and aseptic and delivery of the surgical pack or kit. Check indicator for expiration date and lot number prior to use. Sterilization. Saturated steam under pressure is one of the oldest and reliable methods used to sterilize medical instruments. The CDC recommends steam sterilization as the process of choice because it is efficient, fast, and inexpensive. It is important to monitor the ongoing performance of the sterilizer, as it is difficult to determine unless you use both indicators and performance metrics. Sterilizers heat distilled water under pressure. Moist heat is created and rapidly kills microorganisms to the point of sterilization. Some common steam sterilizer cycle parameters are 250 degrees Fahrenheit, 121 degrees Celsius for 30 minutes, 270 degrees Fahrenheit, 132 degrees Celsius for 10 minutes, 273 degrees Fahrenheit, 135 degrees Celsius for 4 minutes. Follow manufacturer instructions for use to determine increased temperatures and decreased time requirements. Sterilizers should be monitored for efficiency with the appropriate mix of biological and chemical indicators on a daily and per pouch basis. Biological indicator is used to test sterilizers at least weekly. Class 5 integrating indicator is used to monitor every load. Steam chemical indicator is used to monitor every pack. Biological indicators, BI, provide users the highest level of sterility assurance and contain bacterial spores in a self-contained plastic vial. Sterilizers should be tested with a BI at least weekly, preferably daily. Daily testing helps offices that run their sterilizer frequently document successful testing and identify sterilizer failures sooner. The Spore View in-office biological indicator provides customers with test results in 24 hours. Testing is done by placing a BI inside a peel pouch and processing it with the first load of the day. After processing, the biological indicator is activated by crushing the side of the indicator and then incubated for 24 hours. Results are registered by writing in the logbook. The FDA has cleared the Class 5 integrator as the equivalent to a biological indicator. This is used for tabletop sterilizers and should be included with every load. The advantages of the Class 5 integrator identifies sterilizer failures immediately, confirms that sterilizers are working properly between weekly biological indicator tests, eliminates the release of non-sterile instruments, and has the highest level of sterility assurance. The sterilizer starter kit comes with everything you need to conduct steam sterilizer testing. Product is ideal for customers with multiple types of sterilizers, as this product is also certified for use in chemical vapor, dry heat, and EO gas processes. Each box contains spore strips and culture media to be aseptically transferred for final BI test results after 7 days incubation. Includes calibrated dry block incubators at 60 degrees Celsius for steam and chemical vapor and 37 degrees Celsius for dry heat and EO gas. Sterilization pouches are the most frequently used form of packaging in physician offices. CDC guidelines state that a multivariable indicator should be included in every pouch to verify the parameters for sterilization, time, temperature, and steam have been met. Sterilization pouches with SureCheck technology come printed with an external and internal multi-parameter chemical indicator. This eliminates the need to add a separate indicator strip inside, saving money, time, and reducing processing errors. While sterilizers can and do mechanically fail, Operator error is the leading cause of sterilizer failure, i.e. cold start, wrong cycle, overloading, and improper packaging. Failure to perform basic maintenance per manufacturer instructions, such as replacing door seals, cleaning exhaust ports, etc., may also lead to mechanical failures. CDC guidelines state that sterilizers that fail the weekly spore test should not be used until a pass test is recorded. Storage and delivery. Sterile items should be stored in a manner that reduces the potential for contamination. The shelf life of sterile items is event-related and depends on the quality of packaging material, storage conditions, and amount of handling. For quality assurance purposes, expiration dates should be checked prior to use and at least monthly, and recorded for record-keeping purposes. Sterile packages should always be handled with care. Avoid dragging, crushing, bending, compressing, or puncturing, as this can compromise sterility. Be sure to inspect sterile packages before distributing. Do not use any package that is damaged, wet, stained, or opened. Infection prevention practices, including the cleaning, packaging, and sterilization of instruments, are points of emphasis for the CDC and accreditation organizations, as well as the Department of Health. We have covered a lot of information in today's session on cleaning, packaging, and sterilization. The goal of Crosstex International is to provide you with products and solutions that both improve practices and reduce costs. If you need any assistance regarding regulations, product selection, best practices, training, or operational support, please call us